So here we have a function given by 1 minus 1 over x divided by sine pi times x minus 1. So we have to determine the limiting value when x approaches 1. When we do a direct substitution for the value of x, we have 0 over 0, so which is an indeterminate form, meaning we'll need to simplify our given function. So let us begin by first simplifying the numerator. So we have limit x tending to 1. So we will have x minus 1 over x times sine pi times x minus 1. Now what we're going to do, we're going to change the limit. So we have limit h tending to 0. So that means we are going to replace x by h plus 1. So we have h plus 1 minus 1 divided by h plus 1 times sine pi of h plus 1 minus 1. So that will leave us with limit h tending to 0. So we have h in the numerator divided by h plus 1 times sine pi times h. Now what we're going to do, we're going to multiply the numerator by pi and we're going to divide by pi so that we have a standard limit. So we have 1 over pi times limit h approaching 0. So we have 1 over h plus 1. And we also applied the limit to our second function, which is pi h over sine pi h. Now let us apply the limiting value. So we have 1 over pi times 1 over 0 plus 1, and as per the definition, pi h over sine pi h is going to be 1 when h tends to 0. So this is 1. So our final limiting value is going to be 1 over pi. Let us do another problem. So here we have the function tan 2x over x minus pi over 2. We need to determine its limiting value when x approaches pi over 2. So let us begin by changing the limit. So we have limit h approaching 0 tangent of 2 times. So now x will get replaced by pi over 2 plus h divided by pi over 2 plus h minus pi over 2, which will be equals to limit h approaching 0 tangent of 2 times pi over 2 will be pi plus 2h divided by h. So tan pi plus 2h will be equals to tangent of h. Now the tangent of 2h. Now pi plus 2h means that our angle is in the third quadrant. So in the third quadrant, tangent is positive, so we'll have a positive tan 2h divided by h. Now we are going to multiply the denominator by 2, and that means we also have to divide by 2, or in the other way, multiply the entire function by 2. Now we know that the limiting value of this particular function when h approaches 0 is going to be equals to 1. So this leaves us with 2 times 1, which was equals to 2. So this is going to be the limiting value of the given function when x approaches pi over 2. Let us move on to the next problem. So in order to evaluate this limit, let us begin by changing the limit from x to h. So we have h going to 0. We have pi over 2 minus, so x will get replaced by pi over 2 plus h multiplied by tangent of pi over 2 plus h, which is equals to limit h approaching 0. So we have negative h multiplied by, now tangent of pi over 2 plus h is cotangent of h. Now we are in the second quadrant. So in the second quadrant, the sine function is positive and tangent function is negative. So we have a negative cotangent of h. So that this gives us limit h multiplied by, now cotangent is the reciprocal of the tangent function. So we have divided by tangent of h So this, per definition, this value, limiting value, is going to be 1. Let us move on to the next question. So we have cotangent of x divided by pi over 2 minus x. We need to determine the limiting value when x approaches pi over 2. So we're going to change the limit from x to h. So we'll have cotangent of pi over 2 plus h divided by pi over 2 minus of pi over 2 plus h. We know that cotangent of pi over 2 plus h is going to be equals to tangent of h. Now we know that this is in the second quadrant. So in the second quadrant, the tangent function and the cotangent functions are negative. So we have negative tangent of x. So we have limit h approaching 0, negative tangent of h divided by, and pi by 2 will get cancelled out. So we have negative h in the denominator, which is equals to limit h approaching 0, tangent of h divided by tangent of h. So as per our definition of limit, the limiting value of tangent of h over h when h approaches 0 is going to be equals to 1. So let us move on to the next question. So we begin by changing the limits. So we have limit h tending to 0, 1 plus cosine of pi plus h divided by tangent of pi plus h whole squared. Now cosine of pi plus h is equals to cosine of h, but pi plus h means we are in the third quadrant. So in the third quadrant, only tangent function is positive. So that means we'll have a negative cosine of h, and that means tangent of pi plus h will be simply equals to tangent of h. So it will be positive in the third quadrant. So we have limit h approaching 0, we have 1 minus cosine of h divided by 10h. So we have whole squared, so we'll have 10 squared whole h. So we have limit h approaching 0, so 1 minus cosine of h will become 2 times sine squared h over 2 divided by tangent squared h. So which is equals to 2 times the limit h tending to 0. So we have sine squared h over 2. So they're going to divide by h squared. That means we'll also have to multiply by h squared divided by 10 squared h. So we'll have, so h squared, so what also we have to do is we have to divide the denominator h squared by 4. That means multiplying by 1 over 4. So we have 2 over 4 times limit h approaching 0 times sine h over 2 divided by h over 2 squared times limit h approaching 0 h over tangent of h whole squared. So as per our definition, the limiting value will be 1 for each of the case. So we have 1 over 2 as a final limiting value of the given function when x approaches pi.